or 1 by 3 to the power n is equal to 1 by 3 to the power 9. Okay. So this implies that n equal to 9. So the ninth term will be 1 by 19683. Okay, clear? Hi, welcome back to our channel Anganastudycente. Today we will solve the exercise 8.2 of your NCERT textbook from question 1 to 25. Okay, and next day we will do the rest problem and then also solve the miscellaneous problem. So let's start our class. Just look at this question. Find the 20th and nth term of the GP 5 by 2, 5 by 4, 5 by 8, dot dot dot. Okay, so we know the 20th term, that means A20 equal to A at to the power 90, and nth term, that means an equal to A at to the power n minus 1. Okay, here A is 5 by 2. Okay, so we have A equal to 5 by 2 and common ratio R equal to here 5 by 4 into 2 by 5. I mean 5 will be cancelled out, here 1 by 2. So this is less than 1. Okay, and just see here 20th term equal to A equal to 5 by 2 and R equal to 1 by 2 to the power 90. So we have, I just write here 5 by 2 into 1 by 2 to the power 19. That means 5 by 2 to the power 20. Okay, that is the 20th term, and this is the nth term equal to 5 by 2 into r to the power n minus 1. That means 1 by 2 to the power n minus 1. That means 5 by 2 to the power n. Okay, that 2 will be the 20th term and nth term of that GP. Okay, now for this, find the 12th term of the GP whose 8th term is 192 and common ratio is 2. Okay, so here let the first term is A. Okay, so 8th term, therefore 8th term, that means A8 equal to A r to the power 7, where r is the common ratio. Here r equal to 2, so just putting here 2 to the power 7. Okay, and this is equal to 192. Okay, so we have or A equal to 192 divided by 2 to the power 7. So we have 192 divided by 32 into 4. So just cancel out 2 here, 2, 4, 8, 3 by 2. So first term will be 3 by 2 and common ratio is 2. So the 12th term equal to A12, that means A at to the power 11. Okay, so here A equal to 3 by 2 and R equal to 2, 2 to the power 11. So here we have 3 into 2 to the power 10. Okay, that means 3 into 32 into 32, 3072. Okay, that will be your answer. Clear? Yeah. Just look at this question. The 5th, 8th and 11th term of a GP are PQR respectively, so that QA square is equal to PS. Okay, so we have here let the first term of GP equal to A and common ratio is equal to R. Okay, then the 5th term equal to A5 equal to A at to the power 4 equal to here P. Okay, this is equation number 1, and 8th term A8 equal to A at to the power 7, that means Q. This is equation number 2, and 11th term will be A11, that means A at to the power 10 equal to, this is equation number 3. Okay, so LHS, here we have to prove Q square is equal to PS. So LHS is equal to Q square. Just square the Q square. Here Q equal to A at to the power 7. So A at to the power 7 whole square. That means A square at to the power 14. Okay, just divide this part A at to the power 10 into A at to the power 4. Okay, we can write this. So here A at to the power 4 equal to A at to the power 10 equal to S, and A at to the power 4 equal to P. So this can be written as PS equal to RHS. So okay, now look at this question. The 4th term of a GP is square of its 2nd term. First term is minus 3. Determine the 7th term. So let the common ratio of the GP is, okay, first term equal to -3, which is provided here, okay. So the fourth term A4, that means A and Q, okay. So here A equal to -3 and we have let the common ratio equal to R, so -3 R to the power 3, okay. And the second term A2 equal to AR, so that will be -3R. This is 1 and this is 2. Now here in question, fourth term is the square root of second term. So this term is the square of second term. That means this term is equal to the square of this. So therefore -3RQ equal to -3R whole square, or -3RQ equal to 9R square, okay. So or -3R equal to 9 implies that R equal to -3, okay. So here in question, determine the seventh term, that means A7. Therefore seventh term equal to A7 equal to AR to the power 6. So here A equal to -3 and R equal to -3. So -3 into -3 to the power 6. Okay. So -3 to the power 6 equal to 9 into 9 into 9. Okay. So 87, sorry, -27 into 81. Okay. That will be 81 and 27. Just multiply this 7, 56, 2, 60. 7, 8. So -2187 will be your answer. Okay. Look at this question. Which term of the following sequence 2 root 2 4 dot 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 is 128? So we have already known that to find out the nth term. So okay. So let here nth term is 128. Okay. So first let the term is nth term. Okay. Therefore an equal to a r to the power n minus 1, and here just see a equal to 2, r equal to 2 root 2 divided by 2, that means root 2. Okay. So therefore a r to the power n minus 1 is equal to 128. Okay. Just putting here the value, so or a equal to 2 r to the power r equal to root 2 to the power n minus 1 equal to 128. Okay. Or 2 into 2 n minus 1 by 2 equal to 128. Okay. Or 2 to the power n plus 1 by 2, okay, equal to 128. Just factor 128, we get 128 2, 6, 4, 2, 3, 2, 2, 16, 2, 8, 2, 4, 2, 2, okay, 3, 6, 7 equal to 2 to the power 7, or n plus 1 by 2 equal to 7, or n equal to 13. So 13 term will be 128. Okay. Similarly, this also you can do at home. So this is your home work. Okay. Now I will do this. Okay. Here a equal to 1/3, that means the first term, and r equal to 1 by 9 into 3, that means 1 by 3. This is r, that means common ratio. So let nth term will be 1 by 19683. Okay. So we know the formula of nth term. That means according to the condition a r to the power n minus 1 is equal to 1 by 19683. Okay. Or here a equal to 1/3, r equal to 1/3 to the power n minus 1 equal to 1 by 19683. Okay. Okay. So just proving here. Here 1 by 3 to the power n equal to 1 by 19683. Okay. Or 1 by 3 to the power n is equal to 1 by 3 to the power 9. Okay. So this implies that n equal to 9. So the 9th term will be 1 by 19683. Okay, clear? Question: for what value of x the numbers minus 2 by 7, x, minus 7 by 2 are in G? We know to find out the common ratio from the terms of a GP. Here, to find out the common ratio, if you divide the second term by the first term, we get the common ratio. You can divide the third term by the second term, you also get the common ratio. If the common ratio are the same, then that terms are in GP. So we apply that process in this problem. Okay, just look. As minus 2 by 7, x, minus 7 by 2 are in GP. So x divided by minus 2 by 7, that means this is the common ratio, equal to, as they are in GP, so the common ratio obviously the same. So the common ratio, that means 7 by 2 minus 7 by 2 divided by 8. So this is the common ratio. Okay, that will be same. So or x square equal to 7 by 2 into 2 by 7. Minus minus will be cancelled out. So 7 cancel out, 2 cancel out, equal to 1. Or x equal to plus minus 1. Very simple. Okay. Then look at this question. Find the sum to the indicated number of terms in each DP in exercise 7 to 10. So here, just look at the question number 7. Here we have to find the 20 term sum. Here up to nth term the sum, and here up to n term, and here up to. So for this first, here a equal to 0.1, r equal to 0.015 divided by 0.15. So that will be 15 divided by 1000 into 15, and here 15 into 100. So 0 will be cancelled out, 15 will be cancelled out, 1 by 10. Okay, that means r less than 1. Okay, so we use the formula Sn. So the sum up to 20 term, that means S20 equal to a into, here r less than 1. So we use 1 minus r to the power n, that formula, divided by 1 minus r. Okay, so here 1 minus r to the power n divided by 1 minus r. Okay, so just put the value here. A is equal to 0.15, 1 minus r equal to 0.1, we can write to the power n divided by 1 minus 0.1. Okay, that means here just apply that formula, and here we get 1 minus 0.1 to the power n. Here 10 minus 1, that means 9 by 10. Okay, so that will be 15 divided by 100 into 10 divided by 9 to 1 minus 0.1 to the power n. Okay, that will be 0 will be cancelled out, 3 5, that will be 5 by 3 into 1 minus 0.1 to the power n. Okay, that will be your answer. And this is the similar type of this, so this is your homework. Okay, and now look at this. Here a equal to 1, r equal to minus a by 1, that means minus a. Okay, and here just look, a not equal to minus 1. So here a equal to 1, a not equal to minus 1. So we have to find the sum to the nth term. So Sn equal to, here as r equal to minus a, that means less than 1. Okay, less than 1. So we use that formula, that means a into 1 minus r to the power n divided by 1 minus r. Okay, so here a equal to 1, 1 minus r equal to minus a to the power n. Okay, this is the second bracket, divided by 1 minus a. So that will be 1 minus a to the power n divided by 1 plus a. That will be your answer. Okay, now this is your homework. This is also easy. Okay, then look at this question. Evaluate summation k equal to 1 to 11, 2 plus 3 to the power k. So just put the value as sum. So we get first k equal to, we put k equal to 1. So 3 to the power 1 plus 2 plus k equal to, we put k equal to 2, that means 3 square, up to this, up to we put the value of k equal to 11. So the last term 11th term will be 2 plus 3 to the power 11. Okay. So here if we divide this 2 plus 2 plus dot 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 2, this is the 11th number of term. Okay, plus we have 3 plus 3 square plus 3 cube plus dot 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 3 to the power 11. Okay. So here we will get 11 2, that means 2 into 11. Okay, plus this, here we will apply the sum of GP to the 11th term. Okay, so here the first term will be 3 and r equal to 3 square divided by 3, that means 3. So r is greater than 1, so we will apply the a into r to the power n, that means 3 to the power n equal to 11 minus 1 divided by 3 minus, so this will be 22 plus here 3 by 2, 3 to the power 11 minus. Okay, that will be your answer. Look at this question. The sum of first 3 terms of a GP is 39 by 10 and their product is 1. Find the common ratio and sum. Okay, so let the term first 3 terms, okay, terms are A, AR, where A is the first term, R is the common ratio, and AR, okay, where A equal to first term, R equal to common ratio. Okay, so we have sum, that means A plus AR plus AR square equal to 39 by 10. Okay, and A into AR into AR square equal to 1, or AQRQ equal to 1, or AR equal to 1, or A equal to 1 by R. Just put the value of A in this equation. Okay, so we get here A equal to 1 by R into 1 plus R square equal to 39 by 10. Okay, or 10 R square minus 29 R plus 10 equal to 0. Therefore, R equal to, just apply the Siddharacharya theorem. Okay, 29 plus minus root 29 square, that means 29 into 29, 841 minus 4AC, that means 400 by 2A, that means 20 equal to 29 plus minus here 441 and here 20. So this will be 29 plus minus 21 divided by 20. So the value of R can be 50 by 20, that means 5 by 2, or here if we subtract 8 by 20, that means 2 by 5. Okay, so we got the value of R. Okay, so the terms will be when R equal to 5 by 2, A equal to 2 by 5. So the terms will be 2 by 5, comma, AR equal to 1 and AR square equal to 2 by 5 into 25 by 4. Okay, that means 2 to cancel out, 5 by 2. Okay, so the terms will be 2 by 5, comma 1, comma 5 by 2, or when R equal to 2 by 5, A equal to 5 by 2. So the terms will be, terms are 5 by 2, comma 1, comma 2 by. Okay, that will be your answer. Now look at this question. How many terms of GP 3, 3 square, 3 cube dot 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 are needed to give the sum 120? So let us assume there need of n terms to give the sum 120. So we need n terms. Okay, so the sum to the nth term of GP equal to Sn equal to A into r to the power n minus 1 divided by r minus 1. Here r equal to 3 square by 3, that means 3 greater than 1. So we use this formula. So just put the value here, A equal to 3, r equal to 3 to the power n minus 1 divided by 3 minus 1. Okay, this will be 120. Okay, just calculate this. 3 into 3 to the power n minus 1 equal to 240. Just cancel out 3 and here we get 80, or 3 to the power n equal to 81. Okay, so for 3 to the power n equal to, here 81 equal to 3 to the power 4 implies that n equal to 4. So we need the fourth term. Okay, clear? Question: the sum of the first 3 terms of a GP is 16 and the sum of the next 3 terms is 120. Determine the first term, common ratio and sum to the n. So let the terms are A, AR, A, R square, the first 3 terms, and the next 3 terms are AR cube, AR to the power 4, and AR to the power 5, where A equal to first term, R equal to common ratio. Okay, so A plus according to the condition A plus AR plus AR square equal to 16 and AR cube plus AR to the power 4 plus AR to the power 5 equal to 120. So just common here A 1 plus R square equal to 16. This is equation number 1, and here if we common AR square R cube, sorry, we get 1 plus R square R plus R square, okay, equal to 120. Here just put the value of this, we get A 1 into 1 plus R square equal to 16. So here R cube into 16 equal to 120. Okay, just cancel out, or R cube equal to 2 cube implies that R equal to 2. Okay, so we got the common ratio and the first term will be A. So just put the value of R in equation 1, we get A into 1 plus 2 plus 4 equal to 16, or A equal to 16 by 7. Okay, and the sum to the nth term, that means Sn equal to A into, here R is greater than 1, so we use A into R to the power n minus 1 divided by R minus 1. Just put the value A equal to 16 by 7 into R equal to 2 to the power n minus 1 divided by 2 minus 1. So we have 16 by 7 2 to the power n minus 1. That will be your answer. Okay, now look at this question. Given a GP A equal to 7 to 9, A means the first term, and 7th term is 64. Determine S7. That means sum to the 7th term. Okay, here 7th term equal to A7 equal to A R to the power 6, where A equal to first term and R equal to common ratio. Okay, so therefore here A equal to 7 to 9, R to the power 6 we don't know R, so R to the power 6 is equal to 64, or R to the power 6 equal to 64 divided by 7 to 9. This equal to 2 to the power 6 divided by 3 to the power 6, or R equal to 2 by 3. Okay, so we have to find the S7. So S7 equal to, here R less than 1, so we use that formula A into 1 minus R to the power 7. Here n equal to 7 divided by 1 minus R. So here A equal to 7 to 9, 1 minus R equal to 2 by 3. That means 2 to the power 7 divided by 3 to the power 7 divided by 1 minus 2 by 3. Okay, so we get here 7 to 9 equal to 3 to the power 6 into, here just 3 will be above, so just here write 3, and here we will get 3 to the power 7 minus 2 to the power 7 by 3 to the power 7, and here 3 to the power 7 and this will be cancelled out. So we have 3 to the power 7 equal to 7 to 9 into 3. So 2187 minus 64 into 2, that means 128. So it will be 2059. Okay. Look at this question. Find the GP for which sum of first two terms are -4 and the fifth term is 4/10 of third term. Okay. So here let the terms are a r square, a r cube, a r to the power 4, where a equal to first term, r equal to common ratio. Okay. So the sum of first two terms equal to -4. So according to the condition, a plus ar equal to -4. Just common here a, 1 plus r equal to -4. Okay. Now the fifth term is 4/10 of third term. So fifth term equal to a r to the power 4. Okay. And third term equal to a r square. So according to the condition, we have the fifth term is the 4/10 of third term. That means a r to the power 4 equal to 4 into a r square. Okay. Just cancel out a r square. We have r square equal to 4. Implies that r equal to plus minus 2. Okay. So we get r. So here by that, if we put the value of r, we get the term a. So that will be, therefore when r equal to 2, a equal to -4/3, and when r equal to -2, a equal to 4. Okay. So what will be the term? So the GP will be two types. Okay. So the first one is here a equal to -4/3, a r, that means a into r, that means -8/3, a r square, that means -4/3 into 4, that means -16/3. And the second GP will be, if r equal to -2, that means the first term will be 4, that means a r equal to -8, and the third term will be a into r square, that means 16. Okay. Now look at this question. In the 4th, 10th and 16th term of a GPR x, y, z, prove that x, y, z are in GP. Okay. So let first term of GP equal to a and common ratio equal to r. Okay. So fourth term equal to a r cube, okay, equal to, by the condition, f a. This is 1. And the 10th term equal to a r to the power 9, that means y. This is equation number 2. And the 16th term equal to a r to the power 15, that means 0. Okay. Now look at this. If x, y, z are in GP, then y by x equal to z by y, obviously. So just see. Now y by x equal to, just put the value a r to the power 9 divided by a r cube, a r to the power 9 divided by a r cube. So we have r to the power 6. Now z by y equal to a r to the power 15 by a r to the power 9, a r to the power 15 by a r to the power 9. So we have r to the power 6. So therefore y by x equal to z by y equal to common ratio. So we can tell x, y, z are in GP. Okay, yes, as the common ratio are the same. Okay. Then look at this question. Find the sum to the nth term of the sequence 8 plus 88 plus 888 plus 8888 plus dot dot. So we can write the sum as 8 plus 88 plus 888 plus dot 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 up to nth term. Okay, up to nth term. So just common here 8. We get 1 plus 1 1 plus 1 1 1 dot 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 in term. Okay. Here just multiply with 9 and divide with 9. So we have 8 by 9. Here we can write 9 plus 99 plus 999 plus 10. Okay. So we have 8 by 9. Here 9 equal to, we can write 10 minus 1. Okay. And here 100 minus 1. And here 1000 plus 10. So we have 8 by 9, and in this we can write 10 plus 100 plus 1000 plus dot 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 n term. And this is the one part, and here 1 there is n1, that means 1 plus 1 plus dot 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 n. Okay, so I am going here. Then look, this is a GP. If we write 10, 100, 1000 dot dot n. So here we will apply the sum to the nth term of the GP. So we can write this as equal to 8 by 9. Okay. And here r equal to 100 divided by 10. That means 10 greater than 1. So we will apply the formula a into r to the power n minus 1. R to the power n minus 1. So here a equal to 10, r equal to 10 to the power n minus 1 divided by 9 minus. Here 1 1 1 up to n, there is n1, so that will be n. Okay, so just that is 80 by 81 into 10 to the power n minus 1 minus 8n by 2. Okay, that will be your answer. Now look at this question. And the sum of the product of the corresponding terms of sequence. There is two sequence, 2, 4, 8, 16, 13, and here 120, 128, 32, 8, 2. So we would product the each of the sequence, corresponding sequence. So we get the resulting sequence will be, if we multiply 2 with 128, we get 256. Okay. If we multiply 32 with 4, we get 128. If we multiply 8 with 8, we get 64. And here, if we multiply 2 with 16, therefore 32. Okay, and half with 32, that means 60. So just look, this is a GP. Okay, with common factor, common ratio half. So this is a GP with first term 256 and common ratio equal to 128 divided by 256, that means 1 by 2. Okay, so therefore sum S here, how many terms? 5 terms. So S5 equal to A into A equal to 256. Here 1 minus r to the power n, as r less than 1, as r equal to half. So 1 minus 1 by 2 to the power 5 divided by 1 minus half. So we get 256 into 2, 1 minus 1 by 32. Okay, so we have 256 into 2 by 32 into 31. So just here 16 into 31. Okay, 496 will be your answer. Okay, so that the product of the corresponding term of the sequence, here two sequences are given, a r square dot dot a r to the power n minus 1 and capital A R up to a r to the power n minus 1 form a GP and find here. This is like as the previous. Just look, here two sequences a r square. So the resulting after product of the corresponding term, resulting sequence after product of corresponding term equal to, just a with a, so small a capital A, and a r, that means a capital A r capital R, and a capital A small r square capital R square. So up to a r to the power n minus 1 r to the power n minus. Okay, then look here, if we take these two terms, okay, so if we divide this a capital A r capital R divided by, so r, if we take these two, a capital A r square divided by a capital A r capital A, so they are also r. So as the ratio of second, and first, or the next term and the previous is same. That is the common ratio. So this sequence is the GP. Okay, and the common ratio is small r capital R. Okay. Now just look at this question. Find the four number forming a GP in which third term is greater than the first term by 9 and the second term is greater than the fourth by. So we first assume the fourth term. Okay, let AR square, AR cube are the terms of GP, where A equal to first term and R equal to common ratio. Okay. So by the condition third term is greater than the first. So if we minus the first term from the third term, we get 9. So according to the condition, A r square minus A equal to 9. This is equation 1, and second term is greater than 4 by 18. So A r is greater than this. So A r minus A r cube equal to 18. So just here, if we common A, r square minus 1 equal to 9, and here if we common A r, 1 minus r square equal to 18. Okay. So just put this value to this, or A into r square minus 1 into r equal to minus 18, or just 9 into r equal to minus 18, or r equal to minus 2. Okay. So we get r. Therefore A equal to, just putting the value of r in here, we get A equal to r square equal to 4 minus 1, that means 9 by 3 equal to 3. So the terms will be, 4 terms will be A, that means 3, and then AR, that means minus 6, AR square, that means 3 into 4, that means 12, and AR cube, that means 8 into 3, that means minus 24. Okay, that will be your answer. Let's look at this question. If the pth, pth, qth and rth term of a GP are ABC, and then prove that a to the power q minus r into b to the power r minus p into c to the power p minus q equal to, there is, let first term of GP equal to capital A and common ratio equal to capital R. Okay. Then the pth term equal to x p, that means x into r to the power p minus 1 equal to A. This is equation 1, and qth term equal to x cube, that means x into r to the power q minus 1 equal to b. This is equation 2, and the rth term equal to x r equal to x capital R to the power r minus 1 equal to c. That is equation 3. Now LHS equal to a to the power q minus r into b to the power r minus p into c to the power p minus q. Just put here the value. A equal to x r p minus 1 to the power q minus dot b equal to x r q minus 1 to the power r minus, and c equal to x r to the power r minus 1 into p minus q. Just right here, x to the power q minus r plus r minus p plus p minus q into r to the power pq minus q, pq minus q minus pr plus r plus rq minus r minus pq plus p plus here rp minus p minus rq plus this all will be cancelled. So there will be x to the power 0 and here will be r to the power 0. So equal to 1 equal to RHS. So okay. Now look at this question. If the first term and the nth term of a GP are A and B, and P is the product of the nth term. Okay. So here just look, let common ratio of GP is equal to R. So the terms are AR square dot 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 A R to the power n minus 1. Okay. So this is a GP. Okay. Here, according to the condition, A R to the power n minus 1 equal to B, as this is the nth term. So, or R to the power n minus 1 equal to B by A implies that R equal to B by A to the power 1 by n minus 1. Okay. Now, P is the product of the n term. So, therefore, P equal to, we can write A into AR into AR square into dot 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 A R to the power n minus 1. Okay. So, here A is n number of A. So, we can write this A to the power n. Okay. And here R equal to 1 plus 2 plus dot 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 n minus 1 term. Okay. So, we know sum of the 1, 2 up to n equal to n into n plus 1 by 2. So, we can apply here that theorem, n into R to the power. Here up to n minus 1, that means n minus 1, and here n minus 1 plus 1 divided by 2. Okay. So, we get A to the power n, R to the power minus 1 will be cancelled out, n into n minus 1 by 2. Here we just put the value of R here. So, we get A to the power n R equal to B by A to the power 1 by n minus 1 into n minus 1 by 2. Just cancel out, we get A to the power n minus 1, sorry, A to the power n dot B by A to the power n minus 2. Okay. So, if we square both sides, P square equal to A to the power 2n dot B by A to the power n. So, this is the AB to the power proof. Okay. This question, so that the ratio of sum of the first nth term of a GP, that means the sum of first nth term of a GP to the sum of the term from n plus 1 to 2n term is 1 by R to the power. So, the ratio between the sum of n term and the sum of the term from n plus 1 to 2n. That means, if we subtract the sum of n plus n from the sum of 2n term, we get this. Okay. Just look here, 1, 2, 3, 4. Just look, AR plus dot 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 AR to the power n minus 1. Okay. Then AR to the power n. This is the n plus 1 term. Okay. Plus dot 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 AR to the power 2n minus 1. This is the 2n term. Okay. So, here we have to ratio this divided by this. So, this is equal to, if we reduce subtract the sum of n term, mean this term from total, we get this. Okay. Here this is the question. So, here Sn divided by S2n minus Sn. Okay. So, just apply that. Let A is the first term and R is the common ratio. So, Sn equal to, that means the sum to the first n term, A into R to the power n minus 1 divided by R minus 1. Okay. And S2n equal to A into R to the power 2n minus 1 divided by R minus 1. Okay. Now, this sum, that means n plus 1 to 2n. So, that will be S n plus 1 sum to 2n term equal to s 2n minus sn, just a into r to the power 2n minus 1 by r minus 1 minus a into r to the power n minus 1 by r minus 1. So just here, right here, r minus 1, if we common a, so we have r to the power 2n minus r to the power n. Okay, so that will be a r to the power if we common, then r to the power n minus 1 divided by r minus 1. Now the ratio between this and this we get. Therefore the ratio will be Sn divided by S2n minus Sn equal to, here Sn equal to a into r to the power n minus 1 divided by r minus 1, and S2n minus Sn equal to a r to the power n minus 1 divided by r minus 1. So r minus 1 cancel out, a will be cancelled out, r to the n minus 1, r to the n minus 1 will be cancelled, therefore 1 by r to the power will be your answer. Okay. Now look at this, A, B, C, D are in GP, so that a square plus b square plus c square into b square plus c square plus d square equal to AB plus BC plus CD. Okay. As A, B, C, D are in GP, so we can write B by A, that means common ratio, equal to C by B equal to D by C equal to K, let, okay, or B equal to AK, C equal to BK, D equal to CK. So B equal to AK, so here just put the value of B, we get AK square, and here just put the value of C, AK C. Okay, so we get B, C and D value. So now just LHS equal to A square plus B square plus C square into B square plus C square plus D square. Just put the value. We have A square equal to A square, B square equal to A square K square, and C square equal to A square K to the power 4. Okay, and here B equal to AK, that means A square K square, C square equal to A square K to the power 4 plus, and D square equal to A square K to the power 6. So from here we common A square, we get 1 plus K square plus K to the power 4, and here if we common A square K square, there will be 1 plus K square plus K to the power 4. So we have K to the power 4 K square, 1 plus K square plus K to the power 4. Okay. Now RHS equal to AB plus BC plus AD. Also just put the value, B equal to AK, so that will be A square, okay, plus BC equal to A square KQ, A square KQ, CD equal to A square K to the power 5. Okay. If we common A square K from here, so we have A square K, and here 1 plus K square, and here K to the power 4 whole square total whole square. Okay, so this will be A to the power 4 K square, and here 1 plus K square plus K to the power 4. Okay, so this is equal to this is, so LHS equal to RHS. Proof. Okay, so that's all for today's class. In the next class we will do the rest of this exercise 8.2, and also we will do the miscellaneous example and the exercise. If you don't watch the previous video, that means that is the concept clearing video. So just watch that video, and to watch that video please visit our channel, and in the playlist of sequence and series you can get that video. If you like this video, please subscribe our channel and press the like button and share with your friends. Thanks for watching our video.